Okay, great. Like Alex said, my interests are nowadays in bilingualism and L2 learning, but actually my main interest is in sentence processing in general. And I use bilingualism and L2 to inform us about how sentence processing in general works. And this talk is actually no exception. So this talk is more conceptual. There will be no new data, but that's just a thing that people have been doing over the pandemic. So I'm no exception here. So I'm going to talk about prediction utility in language processing and adaptation.
You have to put the cursor in the screen.
Cursor in the screen. There we go.
Yeah.
No.
You gotta click it. And click the cursor in the screen.
Oh, click, yeah.
Click the cursor on the screen. So I'm not using this one.
No, and now it'll work.
And now it will work. No.
Now let me come.
I'll just use the enter key.
All right. Doing. All right. And that should be it, right?
Yeah, okay, great. All right, so to situate this all, as a psycholinguist, the big questions that we need to answer are, how do we process language and how do we learn language? And that all is not trivial given the tremendous amount of ambiguity and variability in the language surrounding us. I give a few examples there on the slide. So especially recently, the muffled noises through the masks or over noisy Zoom connections didn't make language processing easier. So one very prominent and popular proposal is the idea of predictive coding. So the idea is that on the basis of your prior experience, you make predictions as what is to come next. You compare your predictions against the input. The deviation or the error, the mismatch between your prediction and the input is what you use to then adjust your experience on which you base future predictions. So it's a circle. So what is prediction? There are multiple different definitions. For the purpose of this talk, it is not really critical, but I really like the idea of some form of pre-activation, and I'll use that later in the talk as well when I'm trying to model a little bit. But why is this all such a big deal? Why is everybody talking about prediction? Well, first of all, it's popular because it was a whole shift in thinking, and I will illustrate that in the next few slides. So it has been a major shift in how we think about cognitive processes. And second, because potentially it's related to language learning. And of course, for people interested in second language acquisition, that's a very nice connection. But as I will show you later, the connection is not really straightforward. So what I'm going to do first is give you a brief biased history of the role of prediction in language processing, then focus on predictive processing in L2, then illustrate the idea of prediction and utility. So that's something that Therese Gruter and I have been using in our chapter. And then I'll talk about adaptation, so that the learning loop and the role of utility therein. And then I'll conclude with some future directions. So you guys can all fall asleep, but if you do fall asleep, the takeaway message of this talk is that groups and individuals differ as to whether they predict and what they predict during language comprehension. And those differences can be explained by differences in means to achieve maximal processing efficiency. So that's the idea of utility. Okay, so let's start with a brief history. So when I was in grad school, the main idea was that bottom-up information was really important. And the whole debate was about when top-down information could steer that bottom-up information. And the debate was between timing, so when in time does that occur? Or, if you're more of a constraint-based processing person, your bottom-up has different possibilities, and the debate was like what type of other information would help select among these possibilities. And especially in people coming from a Chomsky tradition, The idea of prediction was kind of useless because sentences can be completed in an infinite number of ways. So why, prediction would almost always be wrong. So that was just not an issue. And to illustrate how we thought about sentence processing, so if you have a sentence like the cat likes to drink wine, the idea is that at the word wine, you lexically activate the word wine, and only in stage 2, you relate that to the context, and then you have the anomaly. And that's what your N for 100 would reflect, for instance. It would reflect the integration difficulty. So that all turned around at the turn of the century, especially in cognitive neuroscience, the idea that the brain is like a predictive coding machine, a prediction machine, which means that you have an increased role of this top-down information. That's the most important. And then you compare that to what you get bottom-up, and the difference that you get is the new information. That's what you use to learn. That's what you use to adjust your system to the environment. Okay, so the early idea was nixed, and everything is now focused on the role of predictive processing, with the idea that the input actually helps you adjust. So that was also reflected in sentence processing. So now the idea is that now if you have a sentence like a cat likes to drink wine, you have cat, you come to drink, you start to pre-activate all kinds of things that cats are likely to drink. You come to wine, wine is probably not among what you just activated, and that leads to processing difficulty, and that's what your N for 100 reflects. So it's the difference between what you activated and what you get. So that was a difference in thinking, and it was also encouraged by these new techniques. Those are not new by now, but around the turn of the century, they were very new, that convincingly showed that, yes, we can anticipate what comes next in the written or auditory input. So one prominent technique in this field is visual world eye tracking. So this is a paradigm from Ariel Borowski. So in this paradigm, people are viewing pictures on the screen while their eyes are being tracked. And while they're viewing, a sentence is being played. For instance, the pirate chases the ship, and the movement of the eyes is tracked. So what Ariel and other people found is that even before critical information gets mentioned in the input, people already move their eyes to that particular picture. So in our the pirate chases the ship example, the pictures are bones, which is the unrelated distractor. The picture is a ship, which is actually the target in the end. It's a treasure, which is pirate related, agent related, and it's cat, which is action related, because cats can chase. And it's color coded. So the target ship is coded in red. And you see that at the verb chase, okay, can you see that here? No, you cannot see my mouse. But at the verb chase, people already start looking more at the target ship than at anything else. And that is before the ship comes in the input. So that, and similar experiments show that yes, people can actively anticipate what comes next in the input. Sorry, this one. So not only adults do that, also kids do that. So this is the same paradigm used by Ariel Borowski for kids, and they show exactly the same predictive pattern. It's not confined to auditory language. You also see it in sign language. And it's also not confined to the semantic things that I illustrate here. There's also tons of experiments now showing that, yes, people can predict on the basis of syntactic cues like case and gender, or can predict that kind of information on the basis of other information. Okay, so on the basis of all these studies, people were thinking, and on the basis of that idea of predictive coding, one idea was that, oh, prediction is essential, it's everywhere, it's essential for processing and learning. So that was like one extreme of people in the field, and that of course yielded reactions from other people saying, well, these eye tracking experiments are really limited, they're really restricting the context. So it might just be an artifact of the experimental techniques. So maybe prediction is not that important. And also, there are groups that do not predict. So, and these groups that are mentioned in these kinds of papers are almost always L2 speakers that say, oh, L2 speakers do not predict, hence prediction is not that important. I have a question mark there because, you know, it's not as day or night as I presented here. So let me talk about prediction in L2. So the reason why prediction was studied in L2 was just to jump on the bandwagon. Everybody was looking at prediction. So let's look at what L2 speakers do. And indeed, early studies showed that L2 speakers did not predict, or at least not that much. So this is a study by my collaborator, Therese Gruter, done on Spanish. Spanish has a gender system, two-gender system. And in these typical paradigms, you present people with two objects, and these objects can either have the same gender as in the upper row. So those are two feminine labeled objects. And then we have a different gender condition in which, in this case, one of the objects is masculine and the other feminine. So if you ask people to find the, and the is marked feminine, it's la, that determiner is potentially predictive in the lower row. So because one of the objects is masculine, one is feminine, that determiner will allow you to select the object in advance of hearing the word pelota. And that's indeed what they find. So this is a little bit of a difficult graph, but the time unfolds on the x-axis. And the first dotted line, the vertical line, is where the critical word starts. The two solids lines that you see, so on the y-axis, you have the proportion of looks to the ball. And the solid line that you see, it's a bit hard. Can I use a mouse or something? Let's see. No.
You should be able to use the.
Well, there's a pointer here, but then the people at home don't see it. But anyway,
Oh, yeah.
so this line right here is the L1 speakers.
Sorry. Is this working? No, we still can't see it. Interesting. You could totally see it earlier, but yeah, if you could use it.
It's fine. In the different gender context, and you see that right when the target word starts, they already start to move their eyes. So that's a sign of predictive processing. The dotted lines that you see right here are the L2 speakers of Spanish, so L1 English, L2 Spanish, and these lines don't deviate, which suggests that they don't use that gender information predictively. So these first experiments suggested that indeed L2 speakers do not use information predictively. And on the basis of that, some people, including myself, suggested indeed that L2 speakers cannot predict or have a reduced ability to predict. And that could potentially explain some other findings in the literature. But of course, research progresses, and also shortly thereafter, there were tons of studies showing that L2 speakers can predict. So this is one of the graphs that you saw earlier, but it's now with L2 speakers. And you see that like L1 speakers and L1 kids, and also L2 speakers predictively move their eyes to the target ship in this case. You might think, well, what about gaze and gender? And there are many studies by now showing that L2 speakers can use syntactic morphological information predictively. Okay, so L2 speakers do predict. So it's a little bit nonsensical to stay in these two camps. So either prediction is everywhere or prediction is nowhere. What I think needs to happen is do systematic experiments as to when people predict what and what drives that. Because also in, as I'll show later, also in L1 speakers, prediction is not stable. So sometimes people predict, sometimes people don't predict. And it's an interesting question about what underlies that. Not saying, well, people don't predict, hence prediction is not important. So that's the line I want to argue. And research on L2 speakers now becomes really important because L2 speakers have a lot of variability compared to L1 speakers. So they're the ideal population to study what drives prediction. And also there are more sources of variation because L2 speakers have an L1, so you have cross-linguistic influence. So you have additional sources of variation that drive predictions. So in my 2014 paper, I already speculated a little bit on what might happen. So in that paper, I said, well, there's nothing qualitatively different between L1 and L2 speakers in terms of the mechanisms behind prediction. It's what this prediction is based on that's different. So you have difference in knowledge, difference in resources and in timing, and difference in the reliability of information. And as I'll show you on the next slides, that can explain, first of all, why L2 speakers sometimes do not predict where L1 speakers do. And it can also explain why L2 speakers sometimes make different predictions from L1. So let's go over that. And this has to do with Q reliability and Q weighing. And what I'm saying is, of course, not new. You know, it's the competition model by McWhinney and other things. But just to nail home that point, a prediction is based on relations between Qs and what you can predict on the basis of that Q. So a feminine determiner would predict, or la in Spanish would predict, that a feminine noun would come and that a noun is singular. A verb like eat would predict that what comes next would be an edible object. And languages weigh cues differently. So that's, you know, Bates and McWhinney. So English likes word order. So the first noun phrase is typically interpreted as an agent. Case marking languages like German, like case, and you know that people base themselves on case rather than word order. That weighs more heavily. So due to cross-linguistic experience, influence, and also the experience with the L2, L2 speakers may deem certain cues of more importance or more reliable than L1 speakers, or that may, if there are multiple cues, they may weigh them differently. And Tanya already showed some examples of that. So let me show you how this can work. And I'd like to thank Julia for providing me with these data here. So this is an experiment conducted by people from your group on Norwegian. So in Norwegian, you can do something similar to what I showed for Spanish. So you have the indefinite determiner, which is marked for case and which can be predictive of an upcoming noun. So in this particular display, you have a masculine object and a neuter object. And if you use the neuter determiner, in this case, it will be predictive of the apple. So you compare that to a same gender context in which both the critical display pictures are both masculine or both neuter, for instance. And like L1 Spanish speakers, Norwegian native speakers use this gender information predictively. So again, on the x-axis, you see time unfolds, and you see the noun onset there that's the 1, 2, 3rd tick. And the dotted blue line are the eye movements to the target object in the case in which the two objects in the display have a different gender. And you see that way before the noun onset, there is already a differentiation between these two contexts. So this suggests that L1 Norwegian speakers really use that determiner information predictively. So the nice thing about the study by Johannesson is that they also did that with L2 Norwegian groups. So we're actually 3 groups, but I'm going to show you the data for 2. And what I like about this study is that these groups were matched on proficiency. So they had people do a gender assignment study in the L2 Norwegian. And 2 of the L2 groups were L1 Greek speakers. So Greek has gender, just like Norwegian, and L1 Turkish, and Turkish does not have gender. And both groups were matched in terms of proficiency, in terms of gender assignments. So that was really nice. Actually, the L1 Turkish were numerically a little bit better, but I don't think that was statistically significant. Okay, so now let's see how these 2 groups fare in that eye tracking study. So the Norwegians are on the left here, the L2 groups are in the middle and on the right. If you look at the L1 Greek people, so with a gendered L1, you see that they roughly perform like the Norwegians. So very early on, the graphs diverge. The blue line diverges from the red line. So they really use the gender information predictively. The L1 Turkish speakers, on the other hand, you see some divergence, but it comes way later. So when the noun is already presented. So there is something going on. but it's too late to be called really predictive, but there is something going on. The interesting part is that I mentioned these two groups are matched on proficiency. So why is it that one shows prediction and the other not? Well, I think that has to do with the overlapping properties between L1 and L2. So Greek has gender. So these Greek speakers are used to using gender determiners as predictive cue. It's more reliable, and that's what they latch onto when they learn and process Norwegian. So that is one factor. The other factor is proficiency. And you know, it's always a little bit hard to talk about proficiency because mostly these tasks are really global in nature. And like I showed in my previous slide, even if you are proficient, so that was the L1 Turkish were as proficient as the L1 Greek, yet show different predictive behavior. So there's no proficiency effect there. But you know, if you look at lower proficiency, and now if you don't have the knowledge, you cannot use it predictively. And that's what we also see in that same study. They also looked at low proficiency speakers, and these are Greek speakers on in both graphs, but the ones on the right are lower proficiency. And you see that the two lines are exactly on top of each other, so they don't use case or I mean gender predictively there at all. So this suggests that based on your L1, you know, you treat certain cues differently, and that will affect your predictive behavior. Another thing that you could account for with this difference in cue weighting is that L2 speakers sometimes do predict but make the wrong predictions, especially when you have multiple cues going on. And I'm very happy that Tanya already introduced case marking and OVS order and stuff. So this is a by now older experiment by Holger Hopp looking at case marking in German. So in German, as in Russian, you mark the subject as nominative, the accusative is the patient. So you can look at the paraphrases. The first one in A, you have the wolf in nominative, kills, and then the deer would be an accusative, so the deer would be the patient. In the second sentence, the wolf is marked accusative. Then you have kills, and then what comes next is the agent, so that's the hunter. So you can do a visual world study in which you have the wolf in there, the deer in there, but also the hunter in there, and see what people are looking at. And you predict that, you know, if people use case marking as a cue for what comes next, that in the first case, when they hear the nominative wolf kills, that they move their eyes to the deer because that's the patient, a likely patient. But in the second case, when they hear accusative, so accusative, we have wolf accusative kills, okay, so they would predict an agent, so they would move their eyes to the hunter. And that's indeed what you see for L1 German speakers. So this is a really complicated graph, but if you look at the two lines going up, these are exactly the predictions that I just sketched. So the solid line, the solid thick solid line is for the nominative first condition, and those are the looks to the patient, to the deer. The dotted line that you see underneath is a condition for the accusative first condition, and those are the looks to the hunter. So you see that very early on, so you can look at the x-axis here, so at the verb, slightly after the verb where you see the adverb, the native German speakers already moved their eyes to the correct target object. You can also look at L2 speakers. So these were English L2 speakers of German, and these were actually immersed in German for quite a number of years, and they were pretty proficient. And they do something else. And actually, after Tanya's talk, this should not be much of a surprise. But if you look at a gray line in the middle there, that is the line for looks to the deer when the condition is the accusative first condition. So people hear the accusative, hear the verb, and then they initially move their eyes to the patient. So they still have an agent verb patient interpretation there, and they predict the patient. When the second noun phrase unfolds, so when they hear hunter, of course, they start moving their eyes to hunter. So that's all fine. But this suggests that they do make predictions. They start moving their eyes to the patient, but it's the wrong prediction compared to L1 speakers. So how can you explain this? So Tanya has already mentioned that. So there are also differences in cues. So the L2 speakers really like this agent for patient strategy, especially coming from a native English background that doesn't have any case, that doesn't have any weird word orders. I should not say weird as a linguist, but you know what I mean, non-canonical word orders. And so L2 speakers rely on a cue that's most relevant for that for them in the past. So that's why you could account for these kind of data. Okay, so the predictions that people make depend on the overlap in properties between L1 and L2. It also depends on exactly the constructions used. So if you look at more scrambling rather than these pretty marked object initial orders, Judith and Claudia showed that, you know, you can elicit prediction in L2 speakers. It also depends on presence of auto cues. So in a follow-up study of the deer and hunter study, if you impose prosody on top of that, that's marked or neutral, and use slightly more proficient speakers, I mean, some of these proficient speakers do move their eyes predictively to the right agent in the object initial case. So there's all kinds of cue weighing going on as well. So again, it's not all or nothing. It's not you predict, don't predict, or you only use these cues or those cues. It depends on a lot of different things. Okay. So these were L2 speakers, and I really like to stress that L2 speakers are not special, because L1 speakers also differ a lot in what they predict and when. And by now there is a whole a collection of studies varying these different factors. So there is vocabulary size, processing speed, working memory, literacy, cognitive control. So those are more individual differences factors. But also if you manipulate external properties, you see differences in prediction, like external working memory load, syntactic complexity, or the accent in which the stimulus materials is spoken, the task, whether you have people actively predict or not, the presentation rate, or talker reliability, so whether the talker makes a lot of errors or not. So let me illustrate the last point. So this is also research by Holger Hopp, which is also pretty old by now. I think he was the first looking at talker reliability, not completely sure, but it might very well be the first study looking at that. So he had L1 German speakers listen to these sentences in German with case. So find the red button, something like that. These native German speakers were divided up into two groups. One group only got correct sentences. The other group, in the second half of the study, occasionally heard an error. So the speaker would say, well, find the red button or whatever, but the case was incorrect. Sorry, the gender was incorrect. So it would be a feminine determiner followed by a masculine noun, for instance. And the graph is the graph of the two groups. So what you have on the y-axis is a little bit of an unusual measure, but it's the time lag between the movements to the target, eye movements to the target in the different gender versus same gender conditions. So the higher that is, that means that the earlier you move your eyes in a predictive condition. So the higher that value is on the y-axis, the earlier you predict. That's how to read it. And then on the x-axis, you see the blocks of the study. So it was divided into 4 blocks. So again, the second group, the group that's rendered in the solid line condition, receives the error in the third block. And the errors were only like 25% of the sentences, not that many. And you see that in the fourth block, that group just hardly predicts. So the predictive condition only has on average a 50 millisecond advantage, and you can see there's a huge standard deviation as well. So that really affects like how willing people are to move their eyes to the target object, to predicted object, if they hear a lot of errors in, not a lot, but if they hear errors in the auditory inputs, if the speaker becomes unreliable. Okay, so how to account for all this? So we don't want to have like special processes for everything. We do want to try to come up with a theory of how that works. And when Therese and I were writing our introduction chapter to a volume, which some of you have contributed to, is a volume on L2 prediction in L2 processing and learning. We really are stressing the role of what we call utility. And again, we're not the only ones or the first ones to come up with that idea. Also, Kuperberg and Jaeger introduced that issue, and they also rely on prior literature. So it's nothing that we are inventing from scratch here. But the idea is that, you know, as a listener, your goal is to maximize processing efficiency while minimizing prediction errors, because errors are costly. And that results in a trade-off between predicting and not predicting, and it's a continuum. So if you don't predict, processing becomes costly because you need to activate everything from scratch. You know, bottom up, and you need to, you know, activate everything, and that's costly. On the other hand, if you make detailed predictions, that might be costly too, because, you know, you can make errors, and errors are costly. Also, I think Kuperberg and Jaeger also associated cost with prediction itself, so metabolic cost, but I'm not sure whether you need to assume that. But anyway, there's a trade-off between predicting and not predicting. And what you do as a listener, and this is pretty much implicit, is trade off the reliability of your cue, your context, your resources, your timing, your goals and tasks to come up with the optimal solution. So in case of an L2 speaker, especially if you're not so, if it takes a lot of effort to process things, I mean, you're lagging behind in time, you're lagging behind in resource. Well, you know, let's go with the most reliable cues that we have. Agent for a patient. Okay, let me go with that, for instance. So that's how that might work. And the optimal solution is therefore dependent on the situation, on the task, and on the individuals and the group. And that relates to all these individual differences, properties that I mentioned in one of my first slides. So whenever I gave this talk in prior venues, people told me, well, you know, is it that people just generate all possibilities and then select the optimal one among them? Like, do they really consciously trade these things off? No, I don't think it works that way. So this is more of a conceptual description. And I think we would need to, and I'd love to work together with somebody on this, we need to model what actually goes on, or try to come up with some mechanisms that could help us predict when people predict what. And especially for you, I am speculating a little bit here. So how could this work? So without introducing a lot of, you know, conscious weighing off of possibilities. So let me come up with a hypothetical situation in which you have an L1 Norwegian speaker in your eye tracking study looking at a glove and an apple. So because they're looking at a glove and an apple, these concepts and, you know, you might call it lexical things will become hyperactive because they're there. And also things associated with them. So for an L1 Norwegian speaker, you know, that apple is neuter and glove is masculine, and all other information will become active. Okay, then you get your sentence, and the sentence has the neuter determiner in there. As a Norwegian speaker, one of the things you do have in your network of language knowledge is that X is a very predictive cue of neuter nouns. So that's what that arrow indicates. So then you start activating apple because it's all connected. And then at a certain point, that difference between a glove and apple is big enough for you to, you know, move your eyes more to apple than to anything else. Okay, so I think, I've been thinking a lot about this. So I call this decision criteria. Because I think you do need some kind of mapping function between lexical activation and what you do with your eye movements. So I know that some other people model it a little bit differently, but, you know, for now, let's just call it a decision criteria. You might, you know, do something else there. Okay, so this might account for the L1 speaker. Let's look at the low proficiency L2 Norwegian speaker. So what is different is that the lexical representations are a bit fuzzier, that the links are weaker, you know, whatever your favorite theory is there. So that gender representation is a little bit fuzzier there. So they might know that et is predictive of a neuter, but because things are so fuzzy, I mean, it takes a while before they activate Apple more than anything else, and maybe they never reach that decision criterion. So that might explain what you see for the low proficiency speakers there. It is not quick enough in activating it in order for them to make predictive eye movements. So what about these Turkish advanced Norwegian speakers? So those were the ones who were really good offline, but could not use the gender information predictively. So the fact that they're really good online suggests that their lexical representations are kind of stable, maybe not as good as with an L1 speaker, but I mean, they're there. But how you could model this is that their predictive relation between the determiner and the noun is not very strong because they don't have that in their L1, so they haven't yet transferred that to their L2. So if they hear et, you know, it takes a while before Apple is more activated and reaches that criterion. So that's one way you can account for this. An alternative is that they might change their decision criterion because they're less sure of what the et is doing there. So, you know, they might heighten that criterion in order for them to move their eyes. So let me now look at another hypothetical situation to explain what might happen if things go wrong. So this is a situation that's related to the German speakers that were confronted with these errors. So say that you have your L1 Norwegian speaker, say that they are predicting Apple. So this is what I showed you before, but then rather than Apple, they get a wrongly gendered thing, a wrongly gendered noun in the input. As a result, they can do multiple things. So this is where adaptation comes in, and differences in Q waves. So this is how, you know, prediction can differ from situation to situation. So what people do in this case might differ depending on the talker. So I'm thinking that if they know it's an L1 Norwegian talker, they might think, well, oh, you know, this person just made a speech error or something. I'm not gonna change much, or maybe I'll change my decision criterion maybe shortly for this particular person. However, if this person is not a Norwegian speaker, maybe heavily accented speech, they might adapt a little bit differently. They might say, well, maybe for that speaker, let me make a model of that speaker. So maybe that speaker thinks that Apple is masculine, or thinks that hand shoe is neuter, or glavish is neuter. So they might change only for that speaker their lexical representation, which is kind of wild, but it might happen. Or they can say, well, maybe for that speaker, or for that group of speakers, maybe that relation between the predictive relation between the determiner and the noun is not as strong. And that might generalize over whole groups of L2 speakers, perhaps. And there's some evidence from ERPs that people indeed generalize across L2 speakers and are less sensitive to particular errors that some L2 speakers make, but not others. Okay, so that brings us to adaptation, actually, because based on errors, you can start adjusting your system. So I mentioned that you know, the relation between errors and adjustment and prediction is not all that straightforward. So that's what I'm going to talk about in the next few slides. But to summarize what I told you about before, so the ideas are based on prior experience, you make predictions, but that relation is not straightforward. It's modulated by utility. So your cues, your goals, etc. So like I mentioned at the beginning of my talk, prediction is really hot because people think that, I mean, one idea is that it's really related to learning, language learning. And I like to beg to differ a little bit. Well, first of all, this cannot be the full story because there are situations in which L2 speakers do not predict, but do know. So for instance, these Turkish speakers of Norwegian, they did know the gender, but they don't use it predictively. So they could not have learned it gender by prediction. Okay, so that cannot be the full story. There needs to be other mechanisms that are used in addition to prediction to learn a language. The second remark is that the relation between errors and adaptation is very muddy. So if you have an error, it doesn't mean that you predict, and it's not really clear what people do adjust there. And that's what I'm going to show you here. So now I'd like to illustrate that with one of my prior studies on adaptation. So in addition to prediction, I'm also really interested in adaptation because it's supposedly related. So the idea behind adaptation studies is that you bombard people with material of the same type or of errors of the same type, and then look at how they adjust their processing. And what I used in my study was a pretty classic garden path sentence in English. Of course, I need to go back a little bit. So if you read this, your initial interpretation is that the man purchased both the painting and the drawing. Right? But then, you know, as psycholinguist, you can mess with people a little bit. So I had sentence end this way, which means that the man purchased the painting, that's still intact, but now the wife is buying the drawing, right? So you need to redo that. So that's called an and coordination ambiguity. As a control condition, I replaced and with but, because that more biases towards the causal interpretation. So I expected an increase in reading times that was in the garden path condition, and that could be a sign of error. I mean, you could argue whether this is a prediction error or integration error, but anyway, I was interested in eliciting that error, replicating what other people found. And then my second question was, if we indeed find a garden path effect, does that change over the course of the study? So the more times people have seen this ambiguity resolve towards the causal coordination, does the garden path effect decrease? And that's indeed what I found. So I did a self-paced reading study in which people paced their way through the sentence. And then indeed, I found a garden path effect at the critical position. So where people see was, the red corresponds to the reaction time or reading times there. And you see that the garden path condition, the and condition, had longer reading times than the but condition. And then what I was further interested in is whether that changes over the course of the study. And indeed, it does. So what you see here is in red, you see reading times to the and condition, it was, and blue is the control condition, and you see that the effect nicely decreases over time. My second question was whether L2 speakers do the same thing. First of all, whether they would elicit this garden path effect, and second, whether they also show an adaptation. And I actually had expected adaptation to be larger in the L2 cases because of frequency effects. So there's this thing called inverse frequency effect that you adapt quicker to things that are less frequent. So we had expected actually the adaptation to be even steeper in the L2 speakers. So my L2 speakers were Spanish, L2 speakers of English. They were Spanish majors in Valladolid. They were intermediately proficient. They understood the sentences really well, as we could see from the comprehension question performance. They also showed a nice garden path effect where we expected it, yay. But now if you look at adaptation, they don't. If anything, that effects get larger over time. So that's in the rightmost panel that you see. Okay, so why am I telling you all this? The main issue is actually where the arrow is, that errors do not always lead to adaptation. So these garden path effects you can interpret as errors. You don't see any adaptation of the processing there. Other questions are, of course, well, why don't our L2 speakers adapt? And I speculate a little bit on that in this slide. There's also differences between other studies. There are studies that do find adaptation effects in L2 speakers. Why not? Well, that's something that we need to further study, right? Also, L1 speakers don't always adapt either. So I wrote a chapter together with a grad student, Anjun Chun, an overview of studies on adaptation, and it's a mess. I mean, sometimes you find it, sometimes you don't. Another question is, if people do adapt, what is actually happening? Are they really adjusting their knowledge, or are they adjusting their decision criterion? Are they adjusting their revision? There are many, many possibilities, and still a lot of research needs to be done in order to figure that out. What I do think is going on here is also a utility thing. So when do you adapt? When don't you adapt? What do you adapt to? I think it's also driven by the reliability of prior information. So if you are very certain that your cues are right, you're not going to adjust them. So that's the Bayesian prior. If your prior is really strong, you're not going to adjust that. It's dependent also on your goals, on your attention. There's a study at this year's HSP on the role of reward, that if you reward people, they might adapt. Question then is how long that remains, if it remains after a year still or not. I doubt it, but anyway. So this also leads into, now, is there a relation at all between prediction and language learning? So is there a situation in which prediction can help learning? The answer is it might be if you make prediction really conscious. So if you tell people to actively predict, it might help. So this was a study from Potts and Shanks. They had people generate, it was a vocabulary task. So people saw pseudo words and they had people generate a translation. And then that's predicting a translation. And then people saw the correct response or the correct translation. And people that were in the active prediction group, they learned these pseudo words better than when they were just told to read the words or told to, like, after they saw the feedback or after they saw the real translation, to like report what they had predicted or something weird, something strange. But anyway, the idea or the finding is that if you actively generate, then get the feedback, you learn better, at least in vocabulary, but there's also some indication that it works for syntax as well. Okay, so things like active prediction is related to attention, is related to awareness. That might increase the utility of prediction, and that might indeed lead to more adaptation and more learning. But of course, much more research is needed there. Okay, so let me wrap up. So the big questions are like, how do we process and learn language? One proposal is predictive processing might help, although the relation is not that straightforward. So groups and individuals differ as to when they predict what. And one explanation might be in terms of utility. So people maximize their processing efficiency. And that leads to trade-off between like what's more reliable, what's your goal. So the solution is different depending on circumstances. It's not that we need to give up the idea of prediction. No, it's that we need to better understand what is predicted and when. And that, of course, leads to a lot more studies that systematically manipulate these factors. So the future direction are which solution is optimal when. I'd love to do modeling myself. It'd be really cool to see if you can model the different experimental findings out there. There's also a lot of over the lifespan stuff missing. So we tend to study only the 20-year-olds and the 65+ people, or the really young people, but in between we don't. It might also be nice to look at naturalistic situations. I know some people have been looking at audiobooks in that respect. And it might be also nice to look at like learning app or classroom applications in this respect. So is there indeed a way to increase learning, maybe by having people actively generate their prediction? Okay, so if you want to read up on this, pitching here my book together with Therese. So it's a collection of chapters written by others on prediction in second language processing and learning. And most of what I said today, not all, but most, is in chapter 1 of that. And then I also have a forthcoming chapter in the handbook of second language acquisition and neurolinguistics that also covers part of what I discussed today. Okay, so before I'd like to thank you, I'd like to thank all the people that I have been working with recently. Of course, primarily Therese Gruter, with her I wrote the chapter, but also some people around here and people in my lab and people in my university, like Eleonora Rossi and Jorge Waldesgraf. Okay, so thank you so much for your attention.
Some time for questions. Yeah. Jason.
I'm no expert. So.
Yeah. Janina. And then.
You did?
So much.
Yeah, okay.
For an insightful talk. I have something like to follow up to our brief conversation yesterday. But in your conceptual model of prediction, where you know we show levels of adaptation stuff, is there room for inhibition at all, given that there is work showing that cognitive control predicts?
Yeah. And I haven't really thought this out, but yeah, there's stuff going on that might be really cool to model. And you know, my modeling expertise is not so great, so I'm not sure whether you actually need inhibition or whether you can account for it in other situations. But I would, yeah. What? Yeah. But I like to point out, like here, even the so these are the German speakers. Even the German speakers briefly look at the patient here in the accusative first order, and then they don't. So you need to have a mechanism that that you know, maybe activation here would deactivate that here. So maybe have a limited number of resources, and if you go more this way, then automatically this gets less. I don't know, but yeah, there's definitely indications that, you know, sometimes you activate the distractors that, you know, shouldn't be activated, and you need to deactivate. I mean, you also see that for L2 speakers. We go way at the beginning here. So even the L2 speakers, I mean, they activate. So this is the pirate chases the ship. They activate the agent here, the cat, which is related to chase. And that's something that, of course, needs to be modeled as well.
Yeah, I think this is really interesting. Evidence where despite like the total information and the pirate,
Yeah.
sentence that.
Yeah. And there are differences here. Yeah.
Function of proficiency, right?
Right. Yeah. And cognitive control. Yeah. Yeah. Oh, and then speaking of inhibition, there is a study by Dave looking at unreliable speakers, and her participants are elderly. So, so some talker in the study has these nonsensical things. So, for breakfast, I like to eat socks and stuff like that, you know. And then you can look at the N for 100, and with young adults, the N for 100 start to decrease after a while. So if they say, oh, you know, this person is talking nonsense, let me not pay attention, whatever they're doing to adapt. The elderly don't adapt, except when they have good cognitive control. So when they're able to inhibit, maybe they inhibit their usual prediction. So they predict eggs, for instance, and they're maybe can inhibit it better, and then not show the anomaly effect as largely. So yeah, cognitive control plays a role there too. Yeah.
Or no, sorry.
You did had a question.
It's related to what you just said. So in this study by Bob, also lexical semantic associations could play a role, and I was wondering. I mean, there is this proposal that there are different mechanisms used to predict upcoming information. One is prediction by production, the other one is prediction.
Oh yeah.
So would you assume that the utility of prediction also depends on which mechanism is used? So I can adjust my prediction based on prediction by production, but maybe I cannot adjust them if I use association, because this is less under my control.
Right.
Is this something you would predict?
Yeah, I try not to make that dichotomy. So I believe in a sort of, you know, that also structures are part of your lexicon. So you would activate the structure rather than generating them. But the precision of your prediction is part of that utility. So if your task is to produce, overtly produce, then you need to be precise, and that might lead to some inhibition of alternatives, and you need to very precisely predicted because it needs to come out of your mouth. Whereas if you don't need to produce, yeah, you can have a very level of precision, and that I think is dependent on your task. And I'm not sure how to model that. I don't think you need to have like a association on one end and a production on the other hand. It might be something else than production, but what it is, I don't know. Yeah, but that's my personal inkling, right?
Maybe as two speakers rely to more extent on one mechanism than the other. But that is also yeah, in the case of
right.
That point.
Yeah.
I think it's that's maybe one problem also that's Bob's study was with our study, by the way. That well, you could also use mechanism.
Right. Yeah.
I have two questions.
Yeah.
That's okay. So the first one you just answer yes or no. So you started with very nicely going from like the switch from bottom up to top down processing, and now prediction came. So do you believe that predictive processing is the same as top down processing, or is it a subpart? I remember the was basically saying that.
Yeah. So what you do inside, I mean, it's all dependent on how you define the levels.
Yeah.
So you can say, well, these lexical associations are within the same level. So, you know, that's strictly speaking, they're not really top down. But then the moment, you know, you start talking about levels. So say, you know, these lexical associations start to activate your phonology. I mean, that is top down then. So it's how you define your levels, I think. So, I mean,
because there's a lot of top down processing that you couldn't see as a predictive signal, but it's still sort of pre-activation.
Right. Yeah.
But a related question to that is, I think at least in the eye tracking studies, maybe not in the EEG studies, but a lot of the eye tracking predictive processing studies, there's a lot of the signal that we interpret as prediction might be something like error detection. So if you look at the example you have with the glove and the apple, in many trials you're going to find that the participant is staring at the glove as they hear the cue, and they go, oh, that doesn't match.
Okay.
And then they go and that's not necessarily prediction. It's not necessarily top-down processing.
Yep.
So I think one want to be careful with using parts of error detection signal from a prediction.
Okay.
And they might be.
Yeah. But I wonder how you, I mean, that won't account for other study, not,
It's not everything, right? But it's two different things. Possibly.
Yeah.
I mean, so I mean, what do you think if you stare at the glove and you hear the new gender, it's a car away, because you know, hey, that doesn't match. Would you count that as predictive processing?
That's a really good point. I don't know. Yeah.
I don't think it is, right? So, so it would be. I think both signals are there. Possibly an L2 or L2 that sort of error detection might be something easier than the prediction.
Yeah. Interesting. Yeah. Thanks. Yeah.
All right, Jason, you have a question?
Well, now I have a different question. I didn't ask my first question, but it's more taking your brain about it, right? So, in a sense, not that you really have, but there's kind of a dichotomy here between native languageness versus language and second languageness. But there's a lot of gray area in the world of bilingualism between that. And so I'd love to hear your thoughts about, okay, so how do we model, what contribution would say heritage speakers have? Or let's stay with L2 learners, because there are immersed heritage, there are immersed L2 learners, there are, and not just by proficiency, but in terms of having the opportunity for cue reliability to cumulatively kind of become a reality for them, not just in the context of an experiment or whatever. So with that in mind, and the world not being as dichotomous of black and white in this respect, I want to add something to this, right? And it's somewhat related to what Bjorn was just saying now. So imagine a world in which my lexical representation, so now we're thinking about heritage speakers, it's potentially possible, not all, but some, will have different lexical associations and representations. Yet we build experiments based on, and we all just use these words, error driven, because it's an error if it's not. But if my representation is actually that glove right now, and it might have been, by the way, because I was like, ooh, well, okay, they're both dead, but they're not. Now I know. Okay, so for me, and I'm in the process, and this is potentially a proficiency effect, but I could very well be a heritage speaker. And for some reason, I have Apple and I have glove, right? Now I can't have that error-driven thing because it is my representation.
Correct.
And we build these experiments on the basis of, well, apples are neuter, aren't they? Except when they're not potentially for you. And that's different. We want to get into the granularity of the difference of when it is potentially part of the representation system. If we can avoid labels like lexical entry, it's just a different
Right. Yeah.
How do we do that and not potentially miss some of the prediction for the trees because our experiments don't allow us to see that certain people predict?
Well, but you can. So you could do a gender assignment task with the same participants and say they consistently indicate that the apple is masculine. Okay, now you can analyze your data, and then maybe they predict the apple when the determiner is masculine. And you need to have the right context to measure that, but yeah.
I mean, this is Hogan did this, right?
Yeah.
So you know, and that's great, but you know, sometimes we don't know heritage speakers because we ask them 5 times and 3 times it's feminine, twice it's masculine. What is it? What is it? I just am concerned that
then it would be like the fuzzy fuzzy representation
based on how we set up the experimentation. Even when we are walking away from the hegemonic relationship of what a standard should be. Well, but then what are we going to do? Because we don't know. So you go with what you kind of know in terms of the description, but then maybe we're missing some of the prediction that is actually there.
I mean, I'm sure if you are convinced that in your idiolect, like a certain thing is masculine or neuter, you are going to use that information predictively.
Or maybe, for example, you're a heritage speaker, your experience is, even if you have even if you have a more monolingual-like representation for any given array of lexical items, maybe because of your experience, or as an L2 learner, we idolize a situation, we build these experiments as if L2 learners are only listening to my English, if it's English. In fact, in a classroom, I took Spanish, I took Portuguese, I took Italian. I got much more non-native because my teacher talked for 10 minutes who was or was not native. Yes, I watched some videos, and most of my interactions are with my colleagues who are using gender all over the place. Sometimes I think in L2 studies that show this, it's a miracle that it gets shown anyway, given the stuff that they have to sift through. So the fact that work shows that prediction happens, although constrained or under certain contexts, maybe should be viewed as, wow, they really do predict, because when the cards are so stacked against them, their actual exposure to language and heritage speakers going through all their interlocutors who maybe are not using gender in the same way, if at all consistently. The fact that they can do it is nothing short of a miracle. And maybe the fact that we're tapping it in a certain environment tells us it's even more prolific. Because I mean, I've always liked your approach. Why would it be different anyway? What's really the justification that the mechanism, whatever it is, would somehow magically stop? Right? It's not a specific linguistic mechanism anyway, right? So, so yeah, I don't know if there was even a question.
And I think we're even sensitive to other speakers' distribution. So as if you listen to an L2 speaker, so like a English speaker of Spanish, now you're sort of prepared that they make gender errors, so you're not predicting on the basis of gender, because it will be wrong most of the time. And code switching is another very interesting issue. That you know, if you're in a code switching context, the masculine is no longer predictive because it can be matched with an English translation of a feminine noun.
So I think some things one could do is play with other linguistic cues, specifically linguistic cues like markedness, for example. And you would expect that, you know, prediction could be ameliorated by the relative relationship of the markedness, right? So, you know, outside of a code switch situation or whatever, if you were to insert feminine in Spanish as opposed to masculine, that should be more and less disruptive, right? And you might see some type of effect also in prediction. You know, we know we see this in ERP signals. Markedness matters for amplitude, right? Of the signal, so maybe for prediction as well.
All right, so I have one question, but I'm gonna ask you to add the reception.
Okay.
because then we'll continue there, but let's give